Hello and welcome to my lecture review for the Cybex book, the CompTIA Server Plus Study Guide. It is the 2016 edition. It is published by Wiley, and this is going to be covering the individual chapters prepping for the CompTIA Server Plus certification. Chapter 9 is all about disaster recovery. If there is an issue, how do you recover? So we're going to be looking at the importance of disaster recovery principles and design, and we're going to be looking at backup techniques. These are two core concepts when we're talking about recovery after an incident. So the first major principle that we're going to be talking about in design is going to be hot sites. If there is an issue with your primary physical location, do you have a backup location? And that is what it means by site types. We have three main site types: a hot site, a cold site, a warm site. So if your main location goes down and you need to relocate, what type of equipment is going to be at the relocation center? A cold site would be a building that might have internet installed tomorrow, may have some computers in boxes, but nothing really set up. It's just more opened area, and you can prep it, but you need some time. That's a cold site. A hot site is going to be a site that is 100% ready. You can go from location A to your backup location and everything is already set up. Internet's there, power is there, wireless is there, your data is there, all the computers are set up. You literally can come in, sit down, start working it and going. The problem is a hot site is a lot of money. It's a lot of extra money because it's only used if your primary location goes down. So big businesses typically will do a hot site, and they may kind of lease this so that there is one hot site between 4 or 5 big businesses, because the assumption is not all of them are going to be using the hot site at a given time. A warm site might be a kind of combination between both of them. They may have power and internets, but the computers may be on the desk. You may have to turn them on. But maybe the data's not there. They're kind of ready, but not 100% up yet. So that's a warm site. We also have replication. Replication is not the same as a backup. A replication is a duplicate of data at a given time. So server A and server B, for example, we may share a primary data sets. Well, a backup of that would be a snapshot at a given time, and we're going to keep doing snapshots. That's a backup. Replication is you make a change to the primary data set, it automatically copies to the target or the synchronized or the replicated copy. That means if something happens right now, then it will be replicated to the target. The issue is, if a replication is not something that you wanted, you accidentally zeroed out an account, well, that zeroing out an account would actually duplicate or replicate to the target, and that might overwrite data. Where with a backup, again, a backup is a snapshot in time. So here we're looking at a disk-to-disk type replication. Disk-to-disk is also very not the right word to describe this. This would be storage unit, and how we connect that storage unit could be a modular disk, could be a storage network, and that's going to be slightly different than a server-to-server. A server-to-server is actually going to have dedicated storage underneath the servers that are directly linked to the servers, and the servers themselves will replicate data back and forth. We also have a site-to-site type replication, and again, that's all following the same general synchronous replication, synchronous design. When you make a change one location, it normally copies or synchronizes to the backups. If you look at most cloud storage, that's how this works. You save something in Google Cloud or Office 365 or OneDrive or SharePoint. Well, in reality, as you save a file to a location, it's copying that file behind the scenes to a bunch of other locations. That's that site-to-site type backup. At the end of the day, a business has to operate. If a business doesn't have the services it needs to operate, well, it can't operate. And that's the big thing. That's the entire purpose when we talk about operations. So we have this concept of the continuity of operations. That means if a business goes down, how do we get it to recover? So typically, if we're looking at a call center, how can we ensure that the call center is going to be available? We do what's called a BIA, or Business Impact Analysis. Basically, that's going to be the who, what, where, why, and how things operate of the business. The BIA will tell us specifically, for this organization, these are the processes that are most crucial. If process A, B, C, or D go down, this is the order they need to be recovered. If you're a call center that don't use the website and you don't have a BIA, maybe an IT company coming in trying to recover is looking, oh, well, let's get the website up and running first. Well, if the phones aren't working, the business isn't operating. So the BIA identifies what business processes take priority. We also have a business continuity plan, a BCP, and again, that's going to be how the business will operate and in terms of what situations they can continue to operate. We also have a disaster recovery plan, and that will outline things like backups, procedures, incident response, things like that. The disaster recovery plan, the DRP, Delta Romeo Paul, gives us an outline of what to do in the case of a disaster. If a tornado hits, this is what we do. If a fire hits, this is what we do. If there's an active shooter, this is what we do. These plans allow us to go through scenarios so that we know what to do in a given situation. This allows us to recover faster. This allows us to be able to recover more efficiently. Remember that when an organization is down, they're not generating money or revenue. So, businesses that are down normally is a bad thing. So the faster we can get a business to recover, the better it is for the business. Most of the times when businesses do recover from a disaster, not all businesses actually survive that process. The vast majority of businesses, when they're hit with a major disaster, never actually recover, and as a result, the businesses typically go down. So a disaster recovery plan is actually extremely crucial in the recovering process. Of the businesses that do actually recover, that is because they had a tested and verified and ran through the disaster recovery plan on a regular basis, so the workers knew exactly what to do, management knew exactly what to do in the case of a disaster. That way recovery could be as quickly and as smooth as possible. So we talked about replication, we talked about disaster recovery. What does that mean for data? Well, data is the lifeline of most organizations, so we have to have a way to ensure that data is kept secure and well as is recoverable. So we have what's called backups. We have a full or normal backup. That's where you take a copy of all the data and it copies everything. We have an incremental backup, and essentially that is, it will take everything from the last full backup and then it covers that up. So you have to recover the last full backup and then all the incremental. So I'm actually going to do like a Monday, Tuesday, Wednesday, Thursday type thing. Let's say we do a full and then we do an incremental, and then there's a failure on Thursday. Well, we'd have to recover Monday, Tuesday, Wednesday, and beginning of Thursday. This is only going to cover the last thing since the last backup. So this will have to be loaded, then this will have to be loaded, then this will have to be loaded, because the incremental clears the backup flag. For differential, let's say we do a Monday, we do a differential on Tuesday and Wednesday and Thursday morning, but Thursday night there is a failure. Well, differential copies everything since the last full backup. So on Friday you'd have to load the full backup and the latest differential. This does take more space, but there are some benefits. Recovery time with differential are a lot higher. Snapshot is a snapshot of a system in a given time. Copy on the right is a way to copy the data as it is being written to a storage device. So you may have two storage devices that cover everything. Split mirror, same thing. Selective, same thing. The issue becomes what happened when you're doing a backup and you have open files. Older versions of Windows would not let you do a backup of an open file. Newer modern operating systems allow you to back up an open file, because when you open a file, you're actually not working off of the open file, you're actually working off a copy of the file, and when you actually go to save the file, it will overwrite the original file. One of the big things is data versus the OS restore. When we look at a hard drive, are we backing up the entire hard drive? The Windows portion, the application portion, the user settings portion, or are we backing up just the data? The data is going to be the work documents, the Words, the PowerPoint, the Excel, the other things that are required for the users to actually function. If you take the data and move it from one machine to another, data should just natively work. Where the OS portion has to be unique to the individual system. So a special type of backup is called this bare metal. And in Microsoft Server, you typically have the full backup options if you install it as a feature. So here we have a full backup. We have a backup server that will back up the entire machine. And that's going to be the Windows Server backup feature in Windows Server. And essentially you can schedule it, you can do different options if you want. You can say what you want to back up: the entire system, the bare metal, the system partition, or the local C drive, or all of it. And then you can also say where you want to back it up to. Do you want to do like a linear tape backup? Do you want to do some type of random access like a disk or optical or removable media type backup? All of those are acceptable forms of backups. So best practice is labeling, verifying. You don't just back up. You also want to occasionally test those backups to make sure they actually function. You want to test the restorability. When you're talking backups, it's not always, well, I did a backup. It also is, I did a backup, but I verified I could recover. Because again, sometimes if you always rely on these backups and then you need to use the backup, we have to have trust that that backup data is going to be there and it will be accessible. 1. 2. When we do our backups, we have to understand how long it will take to recover. If we have a backup solution and it takes, 4 days to recover, is that acceptable? And sometimes it is, sometimes it isn't. It depends on the situation. We also have some type of rotation and retention. Normally we cycle through disks. We call it a grandfather, father, son type mentality. Maybe we do a grandfather, we do a main backup every month. We do weekly backups, that'll be the father, and that's going to be daily backups. And each thing that we back up to will actually be separate physical medias. That way we can cycle through our medias. Actually, I take that back. We have, that was the grandfather, father, son, or we have the first in, first out. We grab a disk, and we just run with each disk as we cycle through them. However, if we cycle through disks, we may not actually evenly wear and tear on those storage devices, so that does bring up a whole nother layer of complexity of, is that storage media going to fail anytime soon because one is used more heavily than others? Media storage, normally securely. Whether it be on-site or off-site, it doesn't really matter as long as it's done securely. If it is on-site and the building burns down, well, you lose your backups. If it is off-site, is there a process to move it off-site? And again, securely. We also have to make sure we keep it out of sunlight. We have to make sure it's stored at the correct temperatures. We don't want it freezing, but we also don't want it too hot. We want it kind of in a normal environment. And that is all we had for this chapter. If you have any questions or concerns, please let me know. So I want to thank you for going through this video lecture. If you have any questions, any concerns, definitely feel free to reach out. Remember that it's not enough just to go through the video lecture. You want to make sure you're understanding the material, and we do that by asking questions. So however we have the medium set up for questions, ask them, reach out. Let's discuss some of the topics in the chapter so we can further our understanding of what's going on. I look forward to working with you throughout the remaining of the modules. Thank you.